Electrolytic cells are non-spontaneous cells. In other words, they are not thermodynamically favorable. They take energy from an outside source. Some uses of electrolytic cells would be to separate ores. So if I wanted to recover iron from an iron 3 oxide, or to charge batteries. Some key words that you know that it's an electrolytic cell: a current of electricity is passed through, because again, you're going to take it, you need energy for these reactions. Or electrolysis of. So some background before we can solve the problems. First one, Faraday's Law. Faraday's Law says that the amount of substance being oxidized or reduced at each electrode during electrolysis is directly proportional to the amount of electricity that passes through the cell. Pass more electricity through, more will be oxidized or reduced. So that's why you can combine batteries and make a higher voltage. It's going to occur faster than at a lower voltage. Faraday's constant is 96,485 coulombs per mole of electrons. We saw that constant when we did our delta G is equal to negative Nephi equation. That F is the same F that we're talking about here. But now it's very important that we know that that's for mole of electron. An amp is the voltage going through the cell. We measure voltage in amps, and that's 1 coulomb of charge per second. So if I had 5 amps, I'm going to write that as 5 coulombs per second. If I have 3 amps, I'm going to say 3 coulombs per second. When solving electrolytic problems, these are the steps that we're going to be taking. They're either going to give you the current and time, or they're going to give you the mass of substance. So if they give you the current and time, then you convert that to the quantity of charge in coulombs. Then you'll have moles of electrons, then moles of substance, and then finally grams of substance. If they give you the grams of the substance, you need to find out how many moles you have, then figure out how many moles of electrons you would take. Then we can convert those moles of electrons to coulombs, and then finally to time using the current. Let's see these steps in action on the next problem. So on this one, we're calculating the mass of copper, so we're going to be going in this order, that is plated out when a current for 10 amps is passed for 30 minutes through a solution containing copper 2 ion. When they give you time, you're going to start with the time, so 30 minutes. And it says that we have 10 amps. I'd recommend saying that that's 10 coulombs per second on your paper. We have minutes, but I can't do anything with minutes. I have to get it to seconds. So step 1, I say that for every 1 minute is 60 seconds. Now that I'm at seconds, I can use my amps. There's 10 coulombs for every 1 second. Now I'm at coulombs. When you're at coulombs, we can say that there's 96,485 coulombs for every mole of electrons. So we've done our current and time. We got our quantity of charge in coulombs. Now we're figuring out our moles of electrons. And now we need to figure out our moles of substance. To figure out your moles of substance, you look at what we have. We're trying to go from copper plus 2 to copper. In order to do that, we need 2 moles of electrons because the charge is a plus 2. We're trying to go from plus 2 to neutral. That's 2 electrons for every 1 mole of copper. And finally, I need to get grams. So 1 mole of copper, I look on the periodic table, is 63.55 grams. All my units cancel. I'm left with grams, so now I just plug it in. I get 5.93 grams of copper. So if I run this electrolytic cell for 30 minutes and passing 10 amps, then I can recover 5.93 grams of copper from this solution. Let's say we didn't have a calculator for this problem though. When you don't have a calculator, you want to make sure that you're setting it up using dimensional analysis. We can round things. We can say that this is basically 96,500. We can say this is basically 60. I've got a 2 on the bottom, so I can say that that's a 1, and maybe make this a 30. And then 30 from 96,500, well, that's going to be a 1. And then if I plug 30 into this, then 30 goes into 90 3 times. So 30 goes into 90 3 times, and then bring down my zeros. So about 3,000. And again, I'm just rounding there. And then I've got 30 and 3,000, so that's 1. And 30 goes into that 1, and then bring down my zeros, so about 100. And then I've got 10 and 100, so that's going to be a 1, and that's going to be a 10. And then 10 and 60, that's going to be a 1, and that's going to be a 6. And so I've got about 6 grams. I was pretty darn close, even with rounding these numbers to 96,000. Actually, I rounded it to 90,000 when I divided the 60 from 90. So you don't have to use the exact numbers, because if it was a multiple choice problem, when you wouldn't have a calculator, none of the answers are going to be that close. And if you did have 2 that were pretty close, then you could go back and from the narrowed down answers, pick one of those 2, could go back and resolve without rounding as much, but at least you've narrowed it down more than you had. So let's go ahead and try this one. This one, you're given grams. So we're going to go backwards. So this time we're going to start with grams. We have 10.5 grams of silver. So I need moles of silver. So grams, mole of silver. 1 mole of silver is 107.87 grams. Now I need moles of electrons. Well, I'm trying to go from silver metal, which is just Ag, to Ag plus. So for every 1 mole of silver, I need 1 mole of electrons. Now I need to find my quantity of charge in coulombs. For every 1 mole of electrons, there's 96,485 coulombs. And now I can use my current. It says I'm at 5 amps, so that was 5 coulombs per second. So 5 coulombs for every 1 second. And it doesn't say how long in minutes or how long in hours. So I'm going to go ahead and convert to minutes just so it's not so big. But if it didn't specify, then you could have left it in seconds. So 60 seconds, 1 minute. Let's go ahead and plug it into the calculator and solve. So I get 31.3 minutes. If you wanted to try solving this one without a calculator, you can pause that and see how to reduce that down to try to get around 30. Lots of different ways to solve it. It doesn't really matter where you simplify, you're just going to start simplifying. So I could say that I have 10 and basically 100, so that's 1 and 10. And since I have 1 and 10, I can say, well, that's 10, so let me get rid of that 10 and move the decimal over for this. So 9,600 or 9,650. So I took away one of the numbers because I divided by 10. Then I could divide by 5. I could round this to 10,000 and divide by 5, or I could also just do some division and do 5 divided by 9650. So that's 1. I have 46. That's 9 then, so 45. 15 is a 3, and then a 0. So then 1930, and that's a 1. And then I've got 60 divided by 1930. So first I could divide by 10 for both and say that that's a 6, and that's 190. And then 6 and 190, well, that's kind of like saying 6 and, let me just change this to 180. I can say 1 and 30 then. So again, I get 30. The answer was 31. Pretty darn close. Go ahead and pause the video and try this one on your own. Restart when you're done. So on this one, you should have started with 156 minutes. 1 minute is 60 seconds. And then we were using 9 amps. So for every 1 second, we have 9 coulombs. 96,485 coulombs for every mole of electrons. And then we're trying to go from copper 2 to copper metal. So that's 2 moles of electrons for every 1 mole of copper. And then finally, for every 1 mole of copper, it's 63.55 grams. One other thing, if it's a multiple choice problem and I didn't have a calculator, I would just be rounding this to 63 or 64, because if I don't have a calculator, I don't have to put all those decimals. While if it's a free response question, then I'm going to want to make sure I have those decimals for the molar mass. So plugging that in, we get A, 27.8 grams. This one's a little bit different because they want you to determine the amps. Remember that amps is coulombs per second. So you need to figure out how many coulombs and how many seconds in 2 separate equations and then divide them to get your ampage. Go ahead and pause the video and see if you can figure that one out. Restart when you get stuck or have an answer. So my 48 hours, I need to convert to seconds. 1 hour was 60 minutes, and 1 minute was 60 seconds. So I know that goes on bottom. And then I need to find my coulombs. So to find my coulombs, I need to start with grams of lead 2 chloride. And I know it's lead 2, they gave me the 2 there. I convert it to moles. And then for every 1 mole of lead 2 chloride, I'm going to need 2 moles of electrons, because we're trying to go from Pb plus 2 to Pb. And 1 mole of electrons is 96,485 coulombs, which gives me 643,233 coulombs. Dividing those, I get 3.72 amps. So our closest answer is A. The more positive the E naught value, the more the reaction has a tendency to proceed in the direction indicated. We've seen that before when you were given the 2 half reactions. The one that was more positive is going to stay as written. The other one is the one we reversed. So in this problem, we have an acidic solution. It contains 3 ions. Using the E naught values, give the order of oxidizing ability of these species and predict which one will be reduced at the cathode. Well, if it's reduced, and these are standard reduction potentials, the most positive will be reduced first. So of these 3, this first one is the most positive. So cerium plus 4 would be reduced at the lowest voltage, and then VO2 plus, and then Fe3 plus would be reduced at the higher voltage, or after the first 2 have already been reduced out.